Okay, welcome to Journey to Number Theory, and this is the exercises, the problems for Chapter 3, Section 6, and there's problems 22 and then there's a 23. This just gives a slightly different derivation of the partial sums of phi of n. The punchline, of course, as we saw, was that this phi of n, the partial sums are just 1/2 x squared on zeta of 2 plus big O x log x. So to do this, we're going to start back, and they give us a hint with this, we're going to start back with this form of phi of n that we've seen before several times. It's the sum over the divisors of mu d n over d. So if I want the partial sums of phi of n, then this is the partial sums of this expression. And I'm going to use that divisor, the sum identity 2 again, and I can rewrite this sum in this form. Now, having done that, we can sum this one. This is just going to be 1/2. This is a half n plus 1 formula, so it's a 1/2 x over d, the floor of that squared plus the floor of x over d, which I can split up into 2 bits. And we've already seen before that this expression here we proved earlier was equal to 1, and so this second sum is just a half. So that then invites us to study this sum here, the partial sums of mu dx over d all squared, take the floor. So I look at n less or equal to x mu of n x on n, the floor of that squared. And again I can write the floor of x over n as x over n plus big O 1 all squared. Now squaring that out is going to give me I'll get an x squared on n squared times mu of n, and then I'm going to get twice the product of these, so I'm going to get big O n less or equal to x, x on n, and of course the square of this term is just going to give me this sum, which we know is 0, so you don't get anything from that one. And this one I just take the x squared out. This one here I take the x out, and this one here, of course, as we proved before, this is just given by 1 over zeta of 2, and this one here, this is big O x log x from this sum. And if you plug this back into what we had above for the partial sums of phi of n, the result for part C follows immediately. Finally, question 23 is looking at the asymptotics of phi n over n, and the punchline of it is down here to prove that it's x on zeta of 2 plus big O log x when we look at the partial sums of phi n on n. And we do it by firstly showing this result, and then we're going to do this. It's done very similarly to the previous question 22. So again, we start off with this expression for phi of n, and then if we divide the n underneath and then take the partial sums of both sides, we get this expression. We now apply the divisor, the sum identity 2, to this, which gives us this expression here. Once again, this one is just going to be the floor of x over d. And I can write that as then, well, so that's what we had to get. So we're invited now to study this sum. So this sum, just replacing d with n here, we get the sum n less or equal to x of mu n on n, floor of x over n. I can write this then as x over n plus big O 1. And we just expanding that out gives us this expression plus big O sum mu of x on n. This one here we've seen before is just 1 over zeta of 2, and this one here, this is just roughly sum 1 over n, so that's big O log x. And if we plug this back up into the formula above that we got up here, then the part C follows immediately. That is, that the partial sums of phi n over n is equal to x on zeta of 2 plus big O log x. And that's the end of the problems for chapter 3.